So we didn't get through everything. So many topics not covered. Uh, most stuff. Amazingly, understanding computer systems is a lifelong process, journey. And in here, we've given you like this tiny bit of slice of the total amount. That's probably generous. And it's a huge and complex world. Hopefully, though, a better picture of that is not just some slice of the pie, but rather some very thin foundation, and then, everything you build on top of that is here. So hopefully you get a better sense of how to think about how computer systems work, and that carries forward. Yeah. How much of the pie do I have? It's actually strangely similar to this. How much of a pie does a professor have? Just slightly more than the students. That's all you need to know. Like, what do you need to do? Like, you're learning here. I just have to be like here. And as long as we go at the same rate, right, it's fine. That's the secret of teaching. But who knows? There's an amazing thing in the world. The more I'm in this very privileged position where I'm around a lot of these incredibly bright people. Of course, a lot of them are you come through here. Super bright people come through. I have this opportunity to meet you at this kind of fun time of your life, and it's a very humbling thing actually. Lots of bright people in the world. They're all, however much there's always somebody that knows more. So part of it is knowing stuff, and you can't get away from knowing stuff because if you don't know anything, it's just very hard to do things. But the other part is kind of figuring out what you're good at, and I'll talk about that more in a second. And just knowing stuff isn't really enough. So anyway, there's lots of stuff we didn't cover, and stuff I wanted to even talk about here, like certainly a little bit about distributed systems, about security, about multiple processors in a system we didn't talk a lot about. All those things are super relevant. Hopefully, as I said, you have a little bit of a foundation. You can go learn about those things on your own. Now, before we get into this kind of fun last few words, let's do some class maintenance stuff because we have some few things left to do. One thing we have to do is P5, which is nominally due Friday, so that's kind of sad. If you really need that to spill a day or maybe two, that's okay. After that, it's going to be a problem, so please don't. But just send email if you need it to be later than that, and we'll just deal with it. I just want you to be able to have time to finish it, and we'll try to have all the TA support that we can to help you do that. The other thing, of course, is the final. The final, I believe, now is on Tuesday in a week. Which is 5/8, yes, and in the evening. So before the final, we'll have a review. I guess we'll have a review session. The exact timing is not set, but it's probably Monday, something like 4 to 6, and then room to TBA. Depends if we can get a room. So that's when we'll do that, and that will just go over some old stuff. Your questions, some old questions, things like that. And again, you've already seen kind of all the old exams. I think they're all there. So what's on the final? Well, it's a final, but of course, the emphasis is on since the midterm. Emphasis on since the midterm. So that means mostly kind of persistence, starting at disks, going through SSDs, RAIDs, and file systems in between. So that'll be the focus. Is it fair to have a question about concurrency or virtual memory? Sure, but there won't be many of those, and I wouldn't spend my time focusing on those unless, of course, you still haven't learned what those things are. Then it's a great time to learn those things. But if you had only limited time, I would certainly focus on what we've done since the midterm. The midterm came a little bit late. That's just life, how it worked this semester. So that means it's to some extent fewer chapters, but it's a lot of pages. So if you look at the total number of pages, it's actually kind of similar. So a fair amount of stuff to read there if you haven't been following along, or if you have been. So that's the content. We need to figure out a cheat sheet system. I do have all your old ones, so if you want to reclaim them, I will have them out at some point. You have to come by my office and sort through 300 of them. I did find one that I thought was best. I'll share that with you at the review session next time. I have a photocopy of it. The problem is that one doesn't have a name on it, so I don't know whose it is. But anyway, if you want to reclaim old, that's okay. Please come by. Yes, you can do this. Now, do people want to have one extra page because it's supposed to be they have the old stuff and the new stuff? Who's going to say no to that? But that's too much writing if you don't want it. Yeah, you can take your old one, or you can create two new ones. So I guess you get two separate pages or four sides. Is that fair? I don't know. It seems reasonable, right? Four sides, normal size page, all that. So that's up to you. You don't have to use it all. It's okay. You don't have to. The longer this gets, the more it becomes just a book. So don't do that. There is some clever photocopying in the last round, which is fine. I don't care. What other class maintenance things? There are a few people I owe T-shirts. T-shirts are ordered, and of course still have a few contests pending, which we haven't figured out. So some are coming, and you'll get if you're supposed to get one, you'll get it probably next week, early next week. Otherwise, it'll be just resolved afterwards. So there's that, and then what else? You were supposed to do a review of this class. How many people have done that already? Okay, good. Thank you. So those of you who haven't, please go ahead. I haven't checked the percentage. I'll send mail about that. Try to get you to get to some level of percent so the powers that be know that I asked you to do it, I guess. But it's actually very useful. I read through it and look for ways to make things better in the future. And then, of course, at some point, we'll right after this all ends, we'll get a grade and you'll go off and be really happy. So, any other questions about maintenance things? Yes. Right, because you're saying you'd like to have more questions, at least 200 questions. I don't know. I haven't made it yet. It's definitely going to have. I don't know. I'm kind of tempted to make it like really complex questions, but there's only like 5 of them, so you just have like 5 bubbles to fill in. Wouldn't that be awesome? No, because you know why that's terrible? Because it's so easy to cheat then. You just 5 bubbles to copy. It's so easy. Yeah, you could do that too. We got lots of versions. So I don't know, but it'll be something like that. I mean, I think that's fair to say. It might not be just A or B. It might be the C, for example, or D, or maybe E. Other questions? Yeah. 5/8. Sorry, is that wrong? What day is Tuesday? What day is today? Today's the 1st, right? It's on the 8th. Did I write 5/7 on the website? Does anybody know what day this final is? The odds of people getting to the right final are increasingly low. It's on the 8th. Did I write 8 or 7 on the website? Is it 8? You see 7? Did I fix it maybe? Oh, you thought it was an E. Okay. Yeah, it's definitely not on 5E. My bad. Yeah. Yeah, my writing's just gotten worse over the years. That's life. Yeah. Oh, alternate file. I sent mail about that. Did you get that mail? Yeah. So then you should do what the mail said. Oh, the update is that I have not yet looked at your response to that email. Yeah. Yeah. So if those of you who filled something in, I'll get back to you soon. Yeah, there's a protocol there, but I haven't done my step, which is to care about what you filled out. That's true. All right, so we're about to close, which is exciting. It's also too hot in here. I thought before I say some things which are just what I think are useful last words of wisdom, as I claim to have. Do people have any kind of general questions? Some of you, how many of you are like going off to the real world after this class ends? Right, raise your hand high, right? So all very optimistic that you're going to pass the class, which is great. So congrats on the optimism. So good, some of you, not a huge number. And so I wonder if people had general kind of questions of any kind that we haven't talked about in class that we might have. Yeah. Yeah, you. Recommended courses. Okay, let's just take a quick list of this. I'll do this very quickly, actually. Sure. Recommended courses. I won't spend, don't worry, it's not going to be like a 5 hours how to go through the CS major. Yeah, you had one? No? Oh yeah, I know. Intel, yeah, etc. Yes. This you're talking about Meltdown. I really wanted to talk about that in class. I just kind of ran out of time. And Spectre. Um, I'll talk briefly about that. Sure. That's a technical question, not a life question. Sure. Favorite architecture? That's easy. It's Frank Lloyd Wright. Uh, yeah, I'm like too old to have like a favorite processor. Like you just get to a certain age and you don't have a favorite anymore because at some point you realize it had nothing to do with what was beautiful or elegant. It's just whatever won in the marketplace, and then you kind of let go of that. So I'm not going to answer this. Uh, favorite OS, favorite. Yeah, I don't have that anymore. Yes. Well, yet again, Apple stealing from the technology world and turning that into iPods and iPhones. That's a great question. Yeah. I guess I'm not going to answer that one either. No is the answer. That's very funny. Okay, so we've answered that one. Okay, really quickly, let me do this technology one first. The technology one, yeah, okay, one more. Which OS book did I use? Okay, good question. Did I use? Uh, yeah, so I'll do that one in a second. So Meltdown and Spectre are quite interesting. It actually has to do with something we didn't quite talk about, at least the Meltdown side of it, which is we never talked about, like when you pop into the kernel, um, like we kind of assume like, oh, the kernel is maybe just like in physical memory is kind of our simple view of it. But it turns out kernel pages are mapped into virtual memory as well. And they're actually in every address space that you use, there's a piece of actually that all the kernel memory is mapped into that. And so when you're switching between processes, you're just switching the user part of the address space, and actually the kernel part stays the same. Now, generally, a user program can't read the kernel pages because there's protection there that says when you're in user mode, you can't read these higher privilege pages. People thought that was safe for many years. This meltdown, one half of this kind of Intel big bug, which you should just go read about now. You'll actually be able to understand pieces of that. Basically leaks a little bit of information through timing channels. So these timing channels means I can like access one page or another, or one bit of information or another, and time how long it takes. And when I do that, it allows me to differentiate whether like certain things are in a cache or not in the hardware. It turns out that alone is enough then with certain kind of instruction sequences to allow me then to like figure out what's in that kernel part of memory. I'm not, the amount of detail I have to go into to why that's possible would take me another 20 minutes. So I don't think I have time to do it. But the response there is actually kind of an easy OS fix, which is when you now, like in Linux, if you're using this page table isolation, when you go into the kernel actually uses a separate page table, so it doesn't map its structures into every user space for convenience anymore. The Spectre bug is actually much worse, and people are still trying to figure out ways to mitigate it. It's a complex problem, and it has to do with fundamentally how processors do speculation, which is they're always guessing what instructions you're about to execute. And when they do that, they leave footprints in the processor themselves, which you can then use to figure out stuff that you're not supposed to be able to figure out. It's actually just a very big problem, and there's not a really good solution right now. Yeah. No. There's a long story there too, but no. I'm not even supposed to probably say that. So he's a security guy, so he's probably already listening to this talk. Yeah, so whatever. That's a much longer story, which I actually just can't share with you at all. So that's that. And if you're interested, I'll leave a link to a paper about this. It's actually pretty readable, and with the amount of knowledge you have a little bit more architecture knowledge, but you can kind of read and understand how these attacks work. And it's all timing. This hugely fundamental, interesting thing is we think of computing as being timing kind of irrelevant. We don't care that, we just care about instruction sequences. We don't care about how long each step took. But in many places in security, how long things take reveals things that are bad for us. And now it's becoming like a front and center problem in many, many different locations. So that's something to think about. So quickly, recommended courses. I always say just one thing here, which is it's much. When I was an undergrad, I did this completely wrong, which was to I said I want to take this course next, this course next, this course next, and then I would take them with whoever was teaching that course, and inevitably I kind of found like the worst sequence I could through professors where I was an undergrad, which is at Michigan. So I just say to people, which courses you take doesn't actually matter that much. You need to take some subset of courses. You probably can't take all the courses that you can, that we have. So find professors that you like listening to that person. If you like listening to them, you're more likely to get something out of the class than a class that you think the topic is appropriate, but you don't really like listening to the person. So I would just judge it based on the person. The good news is, like the very first day of class, in the first 3 minutes, you have 100% idea of what that person's going to be like. Like you could tell immediately from me, you were going to learn nothing, but I'm going to tell a lot of bad jokes. And then you're like, sign me up. So if that worked for you, great. And I think that's a good way to judge people. You get a good sense. It's just kind of a gut. And they've done studies of this, right? It takes like, if you just do course evaluations after 10 seconds, they're like almost the same as the course evaluations at the end of the semester, however dumb that is. So that's what I would do. One other question I get about this is, should I take, if I'm an undergrad particularly, people ask, like, should I take undergrad courses and kind of go broad, or should I go deep and kind of try to take some grad courses? I would say first exhaust breadth. Undergrad courses are created for undergrads, so there's good to have a breadth of knowledge. Take as many of those as you can. Then if you run out of those, I would then say kind of go up into the grad courses if you really kind of run out. Last question was, which OS book did I use? I used the Tannenbaum book, but that didn't really inform. And what did that mean? Well, first of all, it sadly meant that I didn't get an A in this course, not an A. But what was really funny about that course, when I didn't get an A, I think I got an A minus. We had minuses. Was that I was like, oh, this is interesting, but I kind of felt like it wasn't being explained to me in a way that worked, and that kind of stuck with me for many years. And then, eventually, we tried a lot of different books here. None of them seemed to kind of get what we wanted, and so that, I guess, led to this class. Us writing our own book. So, one quick question, and then I'm just going to wrap up with 2-3 points. Yeah. Yeah. I'm not answering that. No religious wars. You can't trick me. Yeah. Okay. What? Functioning same line bracket or functioning new line bracket? Yeah. Yeah. What's funny is your opinion on that actually changes over time too. So I've had both opinions. Anyway. Okay. So you're not going to trick Emacs this. Yeah. Okay. All those things. Yeah. Probably can guess most of my answers. So I'm just going to say a couple last things, and I'll talk about, very quickly, wisdom. I'll talk about communication. I'll talk about what to work on in your life, kind of broadly. I'll talk about people, and I'll talk about luck, and then I'll end. Luck, Luke, luck. So very quickly, just last words of wisdom. Sometimes I spend longer on this, but this is fine done in a 5-minute style. So wisdom is a point, actually, one of the first systems papers you read in an OS graduate course is a paper by Edsger Dijkstra. And it's about the realization, I've mentioned this in class before, that computer systems are kind of this intellectual thing. That it wasn't just mathematics that was an intellectual discipline, but actually computer science was one too. Something people had to realize over time. But in that paper, he said this very interesting thing, which is that experience doesn't equal wisdom. And people often confuse the things. They say, I've had experience doing something, therefore I must be wise. Rather, his point was, it was experience plus actually thinking about the experience that led to wisdom. That reflection upon what you have done is what leads to some sort of wisdom. Whatever form of wisdom that you're going to get to on your own, make sure you have time for that reflection. If you have time for thinking, then you can really lead a more thoughtful, reflective life, and you may attain this dreaded word of wisdom. Of course, no one wants to think of themselves as wise because that's obnoxious. But things that you learn are things you learn by not only doing, but also by thinking about them. So that's one point. Second point, communication. When I've probably said this before, I say this all the time. I was as an undergrad, my only goal was to avoid speaking in front of people. I had a deadly fear. Have I talked about this in here before? I had a deadly fear of speaking in front of people. Is anybody doesn't really feel comfortable speaking in front of people? And is comfortable admitting that? Yeah. So I honestly the worst thing in class. I remember like in a German class I had, I had to give a speech in German, which is like what's worse than that? What's worse than talking in English in front of people is having to speak in German in front of people when you're bad at German. And I just remember like I almost felt like I passed out getting to the front, and then I like stuttered through this thing, and I felt like I was going to die. And then I went to grad school, and but as an undergrad, you can kind of, classes are big, you can kind of avoid it for the most part. As a grad student, I got to grad school, and the first week I was there, they're like, oh, what are we going to do in this new project that we're working on? Everybody will give each grad student like 20 papers. You go off and read those papers, and then come back and you give a talk and describe them, all the rest of them, so we can kind of all learn from each other. And they're like, and Ramsey, you can go first. So read these papers, and then next week or 2 weeks from now, you have to speak in front of everybody. And not only was it like everybody, it was like actually a future Turing Award winner, two other professors, a bunch of senior grad students who seemed like, they knew an unimaginable amount, talking about knowing a lot about computer systems. These people still today, I would think of as people as knowing as much about computer systems as anybody. And then I'm like, and there's me who's going to read like 10 papers and try to summarize it to them. And my choices at that point were very simple, and I thought about them. One was, I'm going to drop out of grad school after being here 1 week. This is not for me. Or two, I was going to figure this out. And this very funny thing happened. Just by doing it a lot, you become comfortable doing it. You probably kind of don't believe me because I seem like I'm pretty comfortable, and it's true. I really don't get nervous in front of class anymore. I feel comfortable up here because it's not really that weird of a thing to do. What am I actually afraid of? What's the worst thing? I've said all sorts of stupid things. So what's the worst thing that can happen? So what does that mean? It means that wherever you do, no matter how much you're afraid of it, learning to communicate is really valuable. And that's true in work as well as, of course, this is a communication job, but it's wherever you work. It's useful to learn to communicate. Don't shy away from it. Learn how to talk. Learn how to write. Writing is really important, structured writing. And the more you do that, the more success you'll have no matter what you're doing. So communication is super important. I used to think it was just focus on technical stuff. I can kind of ignore communication, and that's a silly way to view it. Communication is just important. If you know things but you can't tell people about them, it makes it very challenging. Quickly, what should you work on? People often ask me, how did I end up like kind of choosing operating systems? I started like most people as an undergrad. I'm like, I'm going to do AI. Because that sounds, like your choices are like, this, or artificial intelligence. I'm going to build an artificial human and a robot. How awesome. That's the coolest sounding thing. So of course I wanted to work on AI at first. I got very lucky that I got this kind of internship at a robotics lab at Michigan, as I mentioned. And that was incredibly useful for me because I got to see what it was like to work in robotics and who was successful at it. And this is where you kind of have to pay attention because it's really useful when you want to do something to look at other people who are successful at it and say, hey, do I want to be like them? Can I do what they do? Can I do it maybe better than they do? And what I noticed, have I shared this story here? I tell all these stories so much and I'm so old that I don't remember. So we spent this whole time, it was really funny. We had this robot, which I will describe as this little box here. And what we would do is we would set up like a big wall like this, and we'd say, robot, go here. And we would write the code to do this, right? So it has this array of sensors, like these little sonars like this. And those, apparently send out a little sound and get a reflection back, and then they give you kind of a distance estimate. Has anyone programmed sonar arrays here before? A few of you. And so we get, we call like, read sonars, read. There's some routine called read sonars. And then we were like, do our fancy CS stuff. And then what this thing would do is it would go, and it would go at like, 1 mile an hour, and it would do this. And it was pretty good. And we were pretty excited, me and this undergrad that I worked with, this guy named Alex, because we actually figured out a thing that wouldn't get stuck in the 3-wall trap. So this is the famous 3-wall trap. And like if you put a goal here and the robot here, a lot of algorithms at the time would do this. They would just go like this. And ours went like a here, and that said 3-wall trap, and then it went around, and it found its way out. And we were so excited. And it did it, like I said, at like 1 mile per hour. Now, what was moment that changed, that made me decide I'm definitely not doing robotics. It was fascinating because this other group was in this lab too, and what they did there was this guy had the same, he had a different robot which this group had built, and they had their sonar array. And instead of like this ridiculous huge wall traps, which how could you not avoid this wall? It's so big. He set up these little pencils, like a minefield, like this crazy thing. And then he like put his target here. And then he's like, okay, is everybody ready? And like this robot had all these tethers on it and stuff for safety. And I'm like, what are they worried about? And then he said, go. And it went, woof. And I was like, what was that? I'm like, ours was like, first of all, there's no way it would just run over the pencils. And secondly, it would run over the pencils much more slowly than he avoided all the pencils. So I went to the guy in charge of that project. This is like surprisingly a wise thing to do. And I asked him, like, how in the world do you do that? And he's like, oh, I'm an expert in sonar. And I know how to do signal processing, and I get much better information than you're getting from your stupid read sonar call. And he's like, and then the CS stuff, you're figuring out how to get around the pencils. I mean, once you know where the pencils are and you feel really sure about it, that's the easy part. And I was like, ooh. So to be good at the robot thing like that, I needed to know not CS. I needed to know something about how to interact with the real world. And that's like physics and science and all this stuff is very complicated. So at that point I was like, okay, I don't want to learn those things. That doesn't sound like something I want to do. And then there was another robot person actually in the lab, and they built this juggling robot. So it's like in a single arm, and you would drop a ping pong ball, and it would go bing, bing, bing. And then you over here, you drop a ball, and it would start going bing, 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 and then another ball, bing, 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 like that. And that was like, I said, what's the secret behind that? And it's, it turned out this guy's a double E, and he knows how to do all this vision processing stuff and all this mathematical stuff, which felt very far away from this CS dream that I had of avoiding physics. After, it's not that I didn't enjoy that stuff, but it seemed like a different kind of knowledge base. So then I switched. I said, you know what, I'm going to go, when I go to grad school, forget all this AI stuff. I'm going to go work on computer systems, because those are just about computer stuff that I like. And I started kind of at the hardware level. And what was good is I studied the hardware a lot, but then I kind of became interested in the level above that, which is the OS. And over time, it turned out to be very useful to like kind of know something at this level, and then kind of build the thing on top of the level that you know. And so that's kind of how I ended up over here. So that's a long-winded way of saying, like, figuring out what type of thing you want to work on, and like what you're going to be good at, and what kind of skills are needed to be good at that thing. It's something you should reflect on. You should think, how am I going to be good at this? I saw in robotics that the people that were good at that time had skills that were much different than I had, A, or B, even wanted. So it wasn't a good idea to go down that path. I should do something else where it's closer to what I wanted. So last couple points, people and then luck. The thing that you will always should, no matter what you do, there's this funny thing that happens. Wherever you go, there's one thing that's constant, which is that you're there. So that's very similar. Like you could say, hey, I'm going to have a job here or there. Seems like a big difference, but it's largely the same to you because you're there. So it's important to remember that. That's the person, right? That's your kind of selfish view of yourself. But the thing that is important about choosing directions and things, sometimes people ask me, where should I go work? And I always focus on, people, because people, who you will learn from is a hugely important thing. Who you hang out with, right? You often act like the people you hang out with. You learn from the people you work with. All those things are determined by your groups, your peer groups. So thinking about those groups rather than the specifics of, well, am I working on, the back end of some compiler at this company, or at this other place I'm building, whatever, a storage system. Those things actually are very similar, even though they sound different. But what is different are the people at those places. And the more you can evaluate that and put yourself in places where you'll learn from the people around you, that they do things that you want to do, and they want to be, they are what you want to be, is a great way to choose things. So people are really important. The other people that are important are, of course, all the people that you've gotten to know in your time. So those of you leaving particularly, like I often think back, like, why didn't I just kind of connect with more people that I kind of interacted with? What happened to all those people? I don't know. But those are the things you end up regretting. Like all these people that could have been friends or could have been people that you stayed in touch with, but you let it go because, I don't know, they bugged you someday or whatever. Later on, you realize all those things are silly. Stay connected to the extent that you can and connect with as many people as you can. Last thing, very quickly, is luck. Um, no matter what anybody tells you, uh, there is some amount of luck that determines random things in your life, big and small, and you wish you could control it, but you really can't. So for me, like I had many cases. I mentioned that I got this kind of internship as a undergrad robotics. I got to work in an undergrad robotics lab. Why did that happen? It's because you applied and I came in second, so I didn't get it. But then the first guy just took a job somewhere else for the summer, and they said, okay, that guy left, so you can do this thing. Otherwise, I absolutely wouldn't be here because that gave me this kind of research experience, which got me into grad school. If I didn't get into that grad school, I'd have a completely different career. Another piece of luck was like applying to grad school. It's like super competitive, getting in. You have to get lucky, just like any sort of tough institution to get into. The way I got into grad school, I later found out because the way they did it where I went to grad school is that there was a professor that would do it and a grad student. They would work together to decide in a particular area, like who should get in. And in that area that year, they were kind of letting in 5 people. I said I was interested in computer architecture actually, and then eventually moved to OS. And so the professor on the professor's list, I was like 9th. So not getting in. And the grad student, for some reason, really liked my application, so I was like 1st or 2nd on the grad students list, some random grad student. And then they averaged them, and I ended up like 5th. And I got in, and did that affect my life? Well, of course it did, because that's where I met my wife in grad school, etc. That's who I worked with in grad. All those things, completely lucky, based on some random grad student deciding that my application looked pretty good for whatever reason. So that's luck. And that's something I remember learning about this when I was 12. One last story. I was 12, and for some reason, a good friend of mine, he was a caddy for golfing. That's how he made money in the summers, this guy named Kevin. And he got me kind of to play golf when I was like pretty young, like 11, 12 or so, 12, 13. And by the way, my parents thought this was like ridiculous. They're like, "Oh, look at you! Are you a businessman now, playing golf on the golf course?" So, my parents are from overseas, and this notion of their son like being this golfer, they just found it was so hilarious. But then I kind of one-upped them by saying we were like taking a trip to California, and my friend was like, "Oh, you got to go play at this San Francisco public golf course. It's this amazing course, like on the ocean." And so we were in California. I'm like, "By the way, can you drop me off at this public golf course?" I was like this 12-year-old. I want to play a round instead of hang out with you all day. And they were just like, they just thought that was the most ridiculous, funny thing. And apparently back then, people really didn't care about their kids very much. So they're like, "Sure, go ahead and play a round of golf with a bunch of these old guys that we don't know." So I played this round with these 3 other guys, and then on one hole, I remember this quite distinctly. I was a pretty bad golfer, but it turned out that people are pretty nice sometimes in golf. So there was like a par 3, and if you know golf, that's a short hole. So here's the green over here, which I'll color in blue, and I was like, here's me golfing, and here's the other people over here, and then I hit a shot. And it like went over here, which is not what you're supposed to do if you don't know golf. But fortunately over here, there was like a tree, and it like bounced off the tree and like went over here. And it like ran in, well, it's right next to the hole, which is good if you don't know golf. And the people, they were like, "Oh, nice one." They're all very polite, this group of people I was with. And I said, "That wasn't a nice shot, that was a lucky shot." And this guy, who actually turned out to be this Irish guy, which is like such a stereotype. You were golfing with some Irish guy, where the game was invented and stuff like that. And he looked at me very seriously, and he said, "I don't want to do an Irish accent." He looked at me. It's just a true story. And I wonder what happened to this guy. He looked at me and he said, "Always remember, luck is a part of the game." And I was just like, wow. And I did always remember it. I mean, I've always remembered it. Luck is a part of the game. So there's so many things you think you can control, but sometimes you hit a tree and the ball goes near the hole. Sometimes you hit a tree and it gets stuck in the tree and you lose the ball. So anyway, it's been a lot of fun. I hope you had fun too, and I will see you at the exam. All right, thanks.